When we have functions that are given as equations, we compose those in the same way that we do for functions given in any other form. So if I want to take f composed with g of 1, that's f of g of 1. So I'll take g of 1, and in this example, g is the function which takes its input and squares it, and then adds it to its input. So g of 1 will be 1 squared plus 1. So that's 1 plus 1 is 2. And then to take f of that, we'll take f of this 2, and f is the function that takes negative half of its input plus 3. So negative half of 2 plus 3, that's negative 1 plus 3 is 2. So f composed with g of 1 gives us 2. If we want to take f composed with g of negative 3, that's going to be f of g of negative 3. So first we'll take g of negative 3. That's going to be negative 3 squared plus negative 3. That'll be 9 plus negative 3 is 6. And then we'll take f of the 6. That'll be negative a half of 6 plus 3. That's negative 3 plus 3 is 0. F composed with g of negative 3 is 0. And finally, if we want to take g composed with f of 4, well, that's g of f of 4. So we'll take f of 4, that's negative a half times 4 plus 3. That's negative 2 plus 3 is negative 1. And then g of negative 1 is negative 1 squared plus negative 1. That's positive 1 plus negative 1 is 0. So g composed with f of 4 is 0. Now, this is a perfectly straightforward way of evaluating the composition. But sometimes we want to write the composition just as an equation of its own, right? We want to think of the function as an equation of its own. Now, you'll notice that in these two functions, we gave different variable symbols to the inputs, right? In g, we gave the symbol t to the input, and in f, we gave the symbol x. That's to help us to keep track of what we're doing in this next step. To write an expression for a composition, essentially, we just plug one function into the other. So we have f composed with g of t. That means f of g of t. So that means we're going to take the function f and apply it to what g of t represents, so to t squared plus t. Well, what does the function f do? The function f says take negative a half times my input plus 3. And now my input is t squared plus t. So now we have an expression for f composed with g of t. And notice this instruction says do not simplify. The reason that we're going to not simplify at this point is that in general, simplifying these compositions involves some skills that we haven't learned yet, and also introduces some complications that we aren't ready yet to discuss. As we meet new kinds of functions, we'll discuss some of those complications and some of those techniques. But for now, we can write down the composition. We're just not necessarily prepared to simplify it yet. Going in the other direction, g composed with f of x. That means we'll take g and apply it to f of x, which means we're taking g and applying it to what f of x represents. So negative a half x plus 3. Now what does g do? Well, g takes its input and squares it, and then adds on another copy of its input. And in this case, its input is negative a half x plus 3. Negative a half x plus 3. And again, we're not prepared to simplify that at this moment, but there's an expression for g composed with f. The reason that I gave two different names to the input variables in that first example was to allow us to easily distinguish which input is which, right? So we're thinking of t as the input of g and x as the input of f. But typically when we meet functions in the wild, they'll all have the same names for their input variables, and it'll usually be x. But that's okay. We just think of this in terms of the input. So if we want to take h composed with k of x, so our h represents the function where we take 1 over our input. Our k represents the function where we take 3 times our input and add 1. So h composed with k of x, that means we'll take h and apply it to k of x. So we'll take h and apply it to 3x plus 1. What does h do? That's the function where we take 1 over our input, and in this case our input is 3x plus 1. So there's our expression for h composed with k. For k composed with h, well, we'll take k and apply it to h of x. So we'll take k and apply it to h of x is 1 over x. What does k do? It takes 3 times its input plus 1, and now its input is 1 over x. There's our expression for k composed with h of x. We can also think of ourselves as taking a big complicated function and decomposing it. So we can come up with two simpler functions that are composed to get a bigger function. Let's see an example of that. Here we have a capital F of x, which is the square root of x squared minus 5. And I think that the obvious way to look at that is as a square root function applied to x squared minus 5. So I think that this is most easily understood as the inside function, which here I've labeled g, is x squared minus 5. And then the outside function, which here I've labeled f, is take the square root of its input. And notice here we said we want to call this f of t. So we can decompose this function, big F of x, as saying first take x squared minus 5 and then take the square root. Right? So f of g of x then means f of x squared minus 5 means take the square root of its input, which is x squared minus 5.